Hello guys, welcome back to Edit. Today we'll see a really cool bouncing ball kind of animation. Okay, that's really long, but I just want to point out a few things. If you didn't notice, it's like in the beginning it's three bouncing balls which kind of react to the beats, and as soon as um, the balls hit the ground or the marbles, they produce a wave. And as the song goes on, as the music goes on, more number of bouncing balls keep adding on, and later on you have a number of bouncing balls with waves, that emit every time the ball hits the floor. Anyways, actually, this video is inspired by a wonderful audio analysis done in processing. It's actually done by a person called Imai Merkin. It's an amazing audio analysis. So it's basically inspired by that, but it's totally done in processing, and it's a bunch of code, OpenGL libraries and all. So it's pretty much like what we did, but we did in After Effects, and he did it in processing. It's a really beautiful audio analysis. Let's watch this for a little bit. Okay, they use really advanced Econis APIs for audio analysis. We're not going to do such advanced stuff here, but we pretty much can get a really cool, bouncing ball. I don't know what you call it. This effect. It's pretty cool in After Effects too. So let me go ahead and go After Effects. Okay, if you didn't notice, basically the bouncing ball is like the basic in every programming language. No matter maybe it's processing or Flash or JavaScript or anything, bouncing ball is considered like kind of like the hello world of animation. But the thing is, After Effects is not not meant to do such programmatic animations like bouncing balls and reactions and interactivity and stuff. But we simulate bouncing balls using a number of expressions, especially thank Philip from Creative Cow. He really helped me get this going. I had some troubles with the porting, with JavaScript and After Effects. So before we actually go deep, let me just go into Grapher. Uh, Sorry for that. So for those of you who are wondering, it's basically the bouncing ball is nothing but a sine wave. So let me just briefly explain what exactly a sine wave is, and let's jump straight ahead into the animation. So basically, sine wave is nothing but y is equal to sine x. Now you get a really beautiful sine wave here. It starts at 0 and it ends at 3.14 something. It's nothing but pi. It starts at 0 and ends at pi. And this is half of the wave. So let me go ahead and put sine 2x. And now, as you can see, the wave completes at pi. So from 0 to here actually from 0 to 1.6, that's pi by 2. Half of the wave is completed, and from 0 to 3.14, that's pi, complete wave is completed. So we can pretty much change the frequency, the amplitude of the waves, and get, we can pretty much do anything with the sine wave, and it's the basis for our bouncing ball animation we're going to do now. And we're gonna go into sine wave, all these sine wave, pretty much advanced. If you really have troubles with understanding all this, this is not complicated math. It's pretty basic math. But if you have trouble, I suggest you referring to one of Lloyd Alvarez tutorials, which deals with a number of sine wave equations, and I'm pretty sure you'll get it easily. Alright, so let me go to After Effects, and here we have a nice comp, and let me create a new solid, and let's make it say 20 by 20, and doesn't matter. So here, let's imagine this is a ball, okay, and we want this to bounce. So for anything, the basic principle for anything to bounce is actually, we're not going to go into like hardcore physics and acceleration, gravity and stuff, but we pretty much make it oscillate and make it look like as if it's bouncing. So to oscillate first, as you know, this is the x-axis and this is the y-axis, and the z-axis is the depth. So let me make it 3D, and to bounce it should oscillate on the y-axis, and on x and z-axis it just needs to interpolate in linear values, and there is no oscillations in those axes. It's only on the y-axis or any other axis if you want. And if you want to make it bounce on the y-axis, then you can make the x-axis oscillate and the z-axis, kind of both the y and z-axis with just plain interpolation. Don't get confused. We'll go everything deep. So first of all, to oscillate it, let me go to click in position, and first of all, just to demonstrate it, let me separate the dimensions, and I'll click it and put math.sine. Here you just can't put sine because After Effects has a JavaScript syntax, and you really need to put those math syntax for all the sine values or sine expressions. And we need a variable, because if we just put 2, it just gives the value of sine 2 and it just stays there. It's a very well-known technique, and we just use time because time changes continuously through the composition. And let me press enter. Now as you can see, it oscillates, but the values are really low, so we just gotta multiply the values, which is what in math it's called amplitude. So let me go ahead and put 100. Okay, now as you can see, it oscillates, but it starts at 0. The y starts at 0 from here, and we wanted to start kind of the center of the composition. Say we want to start at, say, 300. So let's just put 300 plus. Okay, now 300 is a bit too much for this composition because I choose a really small composition. So let's just put value to avoid any. Okay. Now look, as you can see, it's in the center of the composition, and as it goes on, it goes bottom. Unlike in the grapher, where the sine wave actually starts from 0, it goes to the top. It's from 0 to 1. Well, technically it's true, because After Effects, this point is 0, 0, and this point is the end. So 0 starts from here on both x and y axis. So if the value of y increases from 0 to a certain value, it goes bottom. Let's not worry about it right now. Let's just keep it going. So it starts from 0 and goes to the bottom, and that's the end of half of the wave, and then it goes to the top, this, the end of one crest, and then it goes to the top again and then comes to the bottom. So it's, look, it takes at least 6 seconds actually to complete one complete sine wave. So you really can't just use time, because everything you get is in the multiples of pi. So look, from 0 and to complete one complete cycle, you actually get to have somewhere around like 6 seconds approximately. And you really want to have more control on the frequency of the wave. So let me just go ahead and go back to the grapher. Now let me delete this, and okay, now insert brackets, and let me just produce 2 pi x. Now, as you can see, you have a more control wave here, because you pretty much can control the frequency of the wave, because in generally in sine waves they use 2 pi is the complete, I don't know, period, or the period of a sine wave is 2 pi or something. So you it's always wise to use in the multiples of 2 pi, because you always get in the numbers of the wave completes in even, like in like say whole numbers, like half of the wave completes at like 1, or 0.5 or something. Actually, let's make it 2 pi by say 3. Okay, now as you can see, it starts at 0 and ends at say 1.5, and goes back, and it ends at 3. So in the previous case, our wave starts from 0 and ends at some pi and 2 pi. We get in the multiples of pi in the previous case, but now we got the values in the multiples of like 1.5, 3, 4.5, and all. This is actually 1.5, because the axis kind of scale itself into the dimensions here. So this is actually 1.5, and this is 3, and 4.5 and all. And now let's make it 4. And now, as you can see, from 0 to 2, 2 to 4, and so we have a more even control if we use 2 pi, because the period of the sine wave is 2 pi, and 4 is the frequency. So the thing is actually, so if you see here, it actually takes 4 seconds to complete one complete wave. So which is nothing but the one here. I don't know what it's called. I don't remember what exactly it's called. It's called PR, CTR, frequency, whatever. And if you want to play around with it a little bit, you can totally see it takes 8 seconds now to complete one wave, because you see half of the wave is 4 seconds. So let me just put here 1. So it takes now just 1 second to complete the wave. That's pretty cool. Now, as you can see, we need only the positive cycles. We don't need the negative cycles, because if a ball bounces from here to the top and goes back here, it should reflect back on the top. It should not go through the floor. Imagine this plane as a floor. Now when it starts here, we need to go all the way to the top and hit the floor, and again we should bounce back. There's a really simple technique to get that, because we can just convert all the minus values to the positive values. The easy way to do it is actually delete this. There's a thing in math called absolute value, or in some places they call it modulus. So I think in America they call it absolute. So it's actually just a little bar. It's actually it's found right above the enter key on the keyboard, and just write the whole equation there. So 2 pi by 1 and plus arrow, actually yes, actually x. Okay, now we have an interesting phenomenon here, because the mods are supposed to be put on the whole sign, so it's actually an error. So let me put them on, because we want the whole sign value, not just the 2 pi x value to be passed to. So to do that, let me delete this and now press mods and sign 2 pi by 1 x. Okay, that's a basic equation. Now as you can see, it reflects, it starts from here, goes to the top, bounces back, kind of you get the oscillating motion. Now we can change the amplitude the way we want. Say you want to multiply by 2. Look, it bounces, and the trick is here I used different amplitudes at various times for various instances, so we kind of get a random bouncing ball effect. So let's go ahead and do it in After Effects right away. So we are here now, and the first thing you want to do is actually make the sign values all positive. The best way to do it is, unlike the regular math in JavaScript, absolute can be accessed by a little function called math.absolute. Keep it in brackets, and 100 is a little bit too much for this small column, so let me put something like 40. Now, okay, now you see it goes to the bottom, because as I told you, the axis, the coordinate system in After Effects is actually the 0 starts from here. So positive actually goes, the positive values go to the bottom of the column, but not to the top of the column. So we can easily do that later on. So it starts here, it goes down, the value increases and comes back to its original position and reflects or bounces and goes back to the same position. Now the easy way we can do this is to just subtract this. So the value actually gets subtracted from the initial value, so we kind of get the impression of bouncing. So as we talked before, here you don't have much control on the time, because everything here occurs in the multiples of pi. So the best way to do this is sign math.pi. In JavaScript, we just can't type in pi, so it's just math.pi and subtract into 2, actually 2 pi, right? 2 pi by say you want 2 per what do you say, each, the wave takes 2 seconds to actually complete one, what do we call, I don't know. Anyways, so let's just put this in brackets, because it's always good, because sometimes it calculates in a different order. So let's just put in brackets. So okay, now you can see it actually bounces, and per every 1 second we get a nice little bounce. Look, at the end of 1 second, 1 bounce is completed, and at the end of 2 seconds, another bounce is completed, and at the end of 3 seconds, another bounce is completed, and it goes on. So we got the ball or an object bouncing every 1 second. That's the basis for our animation today. So let's actually create the look of it. So Let me delete this. Okay, now coming to the look, I basically use Trapcore Lux to actually simulate the point light effect, the ball, the glowing orb or ball or marble, what do you call it? But thing is, you can totally do it without Trapcore Lux too. If you use Trapcore Lux, it saves you a lot of time, and it basically keeps things clean. First of all, I'll explain everything with Trapcore Lux, and at the end of the tutorial, I'll go through how to do it, how to get the same look without Trapcore Lux. So let me go ahead and create a new solid. Uh, Actually, yeah. Okay, and make it comp size. Actually, make it a lot bigger, 1000 by 1000. This will act as a base of as a floor. Make it 3D and go rotation and make it minus 90. Actually, and you know just put this here and create a new light, point light, and create a new camera, and so we have our basic floor. If you don't want to get this edge, increase the size of the floor and kind of apply a mask and feather the edges so it kind of fades out. Okay, let's look at it later, and let me go to the let me name this base. Go to the material options and decrease the diffuse. Really don't want it to be so shiny. Okay. Now create a new solid. Make it comp size. Apply it. And I generally put this like here. It doesn't really matter. And go to Trapcore Lux. And as you can see, the base layer actually blocking the Lux layer. Okay, so let's call it Lux. Basically, if you guys don't know what Trapcore Lux is, it's a plugin. It's an amazing plugin that creates volumetric lights, and it's pretty cool. It's really nice, and so we basically got our bouncing ball to really visualize it. Let me drop this comp to new comp so we don't get these light icons. It's a little bit bright. So what you're gonna do is go back to the thing and go back to light 1 and make it to light options and decrease the intensity a little bit to like 40%. Now you have a really cool bouncing ball. Oh, sorry, the marble. No, it's not bouncing yet. Okay, now we have a base here. Let's look at the position. We have it's 181 approximately, and it's a white position. It's actually the level of the base. Keep that in mind. And now let's go and start animating it. Okay, now as I have here, let me click P position, and let's get into separate dimensions. So just to make it easy for you guys to understand. Okay. Now, first of all, let's get the bounce on the Y axis, and let's do the thing. Okay, now coming to the thing, we already got the bounce before. Now I'll click this and apply the thing. Math.sign into math.pi divided by, say for the timing, let's call it 2 and into time. Now make sure you close the brackets properly. And let's say the amplitude approximately, let's say by say 40, like before, and apply the whole thing as absolute, just like as we did before. Should work. Cool. Okay, it's bouncing, but we really because the bouncing, it starts from 0, which we don't want it to happen. So what we do is actually start it from the position of the base, which is 181. So let's just subtract. Remember, After Effects has the coordinate system from 0 to 0 starts from here. Now look, we already got a really cool bouncing ball. If you just ran preview for a little bit, it looks really good. Thing is, it's too slow right now, so we can increase it actually. Let's say, right now it takes 2 seconds, so we really want it to happen every 1 second. It would be 1, and let's crank up the amplitude a little bit to say 80. And now look, it happens every 1 second, and it's really cool. And we can go to camera, and as you can see, we have our bouncing ball. Okay, now we got the y-axis right. So what about let's see how much time it takes to actually one bounce. It takes 1 second. That's pretty cool. Okay, now let me alt click this exposition, and look, we need to have random values for x position from which change. Those random values change every second, because here one bounce completes in 1 second, so we need to have the x values change every second. I mean, the random values of x. If it doesn't make sense, it will make sense in a second. Okay, now let me put seed random to get the first set of random numbers, and make it say on 20. You can put any number you want, doesn't matter. Make it true so that you get only one the value of the random value of the number won't change every frame, it stays the same. And let's call a variable a random from 0 to 800. And now let's change the seed again, so we can get a different set of random values to say 42. And let's call it b random 800, and we have to interpolate, animate the value of x position from this point to this point within 1 sec, because our bounce takes 1 sec to complete. So let's interpolate it linear with respect to time, from 0 to 1 seconds, from A to B. Cool. Now as you can see, it bounces from from a certain value to a certain value. You can see here in the comp. Look, it bounces and then stays at the same x position because the values of a and b remain constant after 1 second. So x, the value of x here will remain the same all through the thing. So we need to have different random values every second. And at the same time, we can't use the regular random expression because the value changes every frame. So we need to have something that changes random values every second. So to do that, I have a really good expression called mat dot floor and time. Because if you use the time changes every frame, so we get different random values every frame, and we just can't interpolate those values. So we use an expression called mat.floor. What it does is it basically gives the least integer value of the given number. For example, if I have 8.32 and mat.floor gives the value of 8, say for 0.99 it gives 0, because it's not like it doesn't round, it gives the lowest integer value. It's like the floor, the flooring, the least value integer value. And let's multiply it by 20. And so from, say, when time changes from 0 to 1, it still says 0. From 1 to 2, the value changes to 1. So we can get different random values every second, not every frame, by using this mat.floor time expression. In the same way, apply it to mat.floor time. Okay, now you're expecting, yeah, I should get bounces every second, right? Like, yeah, you do get bounces, but it's all weird. Like, you really don't get anything right because it's all jumpy, because the thing is, we are interpolating from 0 to 1, and after that, we're not interpolating the values. They just change, based on the second, and we need to change this from 0 to 1 to the current time to the next second. So mat.floor time, that's the initial time, wherever it is, and to the next second. Okay, now even though you do this, you really won't get a smooth animation. Look, it's so jumpy. This is a really interesting phenomenon because we pretty much did everything right. No, because as you can see, we need to be interpolating through the values of exposition from A to B, and for 1 second, right? And after that second changes, the value of both A and B change too. So it interpolates from the change value of A to the change value of B. So to avoid that, the change value of A should be equal to the previous value of B. Let's imagine this is the ball and it bounces off from this point to this point to this point. Imagine it's like 3 random points, and these are like imagine these are supposedly the x values. So we are interpolating from A to B. A is a random value and B is a random value. So when the circle interpolates from excuse me, like to 1 bounds, see now this circle, to complete the next bounds, this value should be the A and the next random value should be B, so that this circle will interpolate from this value to this value in the next second. And as soon as it reaches that point, and this value will again be A, this is the concept that's involved in the random values that change, but still they have a certain synchronization between them. Let's go ahead and see how exactly we can get that synchronization between those random values. Okay, now let me go ahead and change the value of 1 to 0.5, so that the wave one bounce actually completes in half a second. Now it's important to note that if you change the values of y position, you have to change the values of x and z too. So because if all the values should interpolate in a certain time frame, and then only we get the bounce, otherwise it's just so choppy and all. Like, look at this right now, it's not all like like a good bounce. It's all the way. Okay, now the thing here is actually, let me suppose say you want to you know change the interpolation values of x. So now one bounce actually completes in half a second, so we need to change the value of t so that we get two random values for every second. So basically we need to divide it by 0.5, so we get two random values for every second, because say if it's 1, it gives 1 when it, divided by 0.5 is actually 2, so it gives two random values every second. And now everything's fine, and you think you get your really nice bounce animation, but it's still choppy because we actually changing the random values twice as much as before. So the interpolation has to occur twice in less amount of time as before. So to do that, let's multiply this by 0.5 and multiply the seed random 2, the second one too, by 0.5, because it has to occur in half the amount of time compared to the previous one, because we're getting two different values of floor here, so that each bounce is just 0.5 seconds, and there will be 2 bounces per second, unlike in the other case where there's only 1 bounce per second. So in the same way, each bounce take half a second, so we have to interpolate this from t 0.5 to t plus 1 0.5. Now it's so confusing here, because you'd think, why should I multiply here with 0.5? Why just can't I put t and t plus 1 is 0.5? Because if you subtract t and t plus 1 by 2, you just get a really like 0.25 t, but your interpolation should be 0.5 t. So just remember that the difference between these two timings is actually the what do you call, the bounce time of the marble or ball. Here the difference between these two interpolation timings is 0.5 t, which is nothing but the time for one bounce. And if you just put t, it changes to 0.25 t, which is half the bounce time. So just change everything to 0.5 t. So that's pretty much it, and hopefully you get your bounce. Now you have a really smooth bounce. It's pretty cool. Now just do the same in for Z, so that you get a three-dimensional bounce. not just two-dimensional. But remember to change the index values. So let's just put multiply by index. So you have a different index ranges. Make sure you put this to put the difference to 1, and there you go. Okay, now the range is a little bit high, so let's just decrease it to 200. Now you have a really beautiful bouncing waves. Now adjust the camera the way you want, and you got it. Now what you can do is actually just duplicate this. You have a bunch of different lights, and now go to light options and change different colors, and it's pretty much anything you want, and change this to green. Cool. Now let's go to the second composition. Look, you have your beautiful bouncing marbles or balls, what do you call it. So now comes last part, to create the base. How to do that? It's pretty easy actually. Let me go back to my little comp and create a new layer, and just make it a little bit big, same size as the base layer. Actually, just duplicate the base layer, that's a lot easier. Okay, now let me call this as wave, actually waves, and now apply radio waves. Now as you can see, it generates radio waves in blue color. Now it is reacting to light. We don't want that. We want the waves to be visible no matter what happens. So just active lights off. Okay, now make sure the lifespan is just like 1 second, and increase the frequency to 2, because we need 2 waves per second, because there will be 2 bounces per second. So that's pretty much how you get wave, and change the color. Say we're animating for the green, go for the green, and decrease the opacity a little bit to 0.6, and just change to triangle or sawtooth or Gaussian, getting a really smooth Gaussian. Okay, now the question is how to exactly sync the bounce to the to the radio wave. It's pretty easy actually. Let me show you. Let me find the green light. This is blue green. Yeah, this is a green light. So we have a position here, and the thing with radio waves is actually the plugin is 2D, so we can only have a 2D producer point. No problem, it's not a big deal. You can pretty much convert it easily. The easy way to convert it is I'll click on the producer point and just type from world. So it converts a point from world space to layer space, and pick with this, and okay, this is kind of like a tricky question. I mean, not tricky, but exposition, or just put transform the position. Yeah, I'll be fine. And click. Now it's so interesting because every time, I'll show you, every time the thing bumps, you produce a wave. It's so cool, like it bumps and you got a wave. And the next it bumps there and you got a wave here. That's pretty much what I did. And it looks cool. Actually, let me just zoom out a little bit. You know what? Just you guys can have a bigger solid and all. It's not a big deal. But let me just show you what exactly I was actually going for. Okay. Now, in the same way, duplicate this and change the color to orange. And change it to, say, light 3 to a different light. And let's run preview it. Now, okay, now we have a really cool bouncing animation, but if you look at it, they all bounce to the same height. We kind of want some randomness. So let's go back to the comp 1 and actually go to one of the lights and copy this. Copy the first path here and paste it here, and let's calculate the length of it. So let's call L is equal to, After Effects has a cool function called length, which calculates the length between 2 points. So let's calculate the length and multiply it. Instead of 80, let's multiply it by L by 2. So look, they go in different directions. I mean, different lengths, different heights. That's pretty much what I did, and I added a little bit of camera wiggle, and just just I didn't actually sync it to the beats. I just calculated the number of beats per second by just in mind. Like it's approximately 2 beats per second, and I just put 0.5 beats per second, and that's 2 bounces per second, and that's pretty much how I did my animation. And it's a long tutorial. I really know that. If you guys have any questions, if you didn't get it's a lot of topics actually to just squeeze in one tutorial, and it's kind of hard to explain many terms. But if you have any questions, just post it in the comments, and I'll be more than happy to answer you.